For the next few examples, we're going to be asked to use composition to determine if two given functions are inverses of each other. And the rule itself is a little bit confusing the first time you see it. So let me kind of motivate this for a second. As we said before, an inverse function will undo what a function did. So for example, if I had a function f that turned 3 into 5 and 1 into 7, and that if g happened to be an inverse of f, and I don't know if it is or not, which is why I'm not giving that f to the -1 notation, if this function is an inverse of this function, then it would take 5 and turn it back into 3. It would take 7 and turn it back into 1. So the idea would be, if I were to compose these two functions, if I were to take f, let's say g of f of 3, here's what would happen. I would take 3, I'd plug it into f, and a 5 would pop out. So g of f of 3 would turn into g of 5. I would then take that 5, plug it into g, and it would turn it back into a 3. So what I started with and what I ended with would be the same. Like what I input would be what I ended up with. And that should work no matter what I input with. So even if I had, like, say, g of f of 1, what would happen? I'd find f of 1, which would give me, of course, 7. So that would become g of 7. And then g of 7 would take me back to 1. So where I started and where I ended would be the same. And in general, what's going to happen is if we compose two functions and they are, in fact, inverses, then if I take g of f of anything I can stick into f, I'm going to get that thing back again. And, by the way, the order shouldn't matter. Like, if I take g of f of, that's the same thing. If I take f of g of x, I should also get back to where I started. I should also get an x. So what we'll do to verify if two functions are inverses is we'll compose it one way, see if we get x back. Compose it the other, see if we get x back. And if that happens both times, then these are in fact inverses. If you're not seeing the difference between this blue and this red statement, check out the next minute of this video and I'll just do an example of this in red. Otherwise, you can stop this video now. This is a little bit different in that let's just look at an actual concrete example. If I said f of g of, say, pick a number from g, like 5, then of course I'd have to find g of 5 first. G of 5 is 3, so that would turn into f of 3. And then f of 3 is 5. So it worked out again that what I had plugged in and what I ended up with ultimately were identical. And so if I plug in an x, I'll get x to pop out. And that's what you're going to see coming into play in the next few examples. We're going to compose the functions and hopefully get just x as our answer every single time. If we do not get x, they are not inverses. If we do get x's both times, they are inverses.